Welcome to episode 19 of Writing a 6502 Assembler in Assembly Language. And in this installment, I'm going to be working on the numeric labels. And I have this little diagram to show you how the numeric labels work. To explain how they work in an assembly language program in the source file, the best thing is to go look at the documentation that I link in the description of every video because it explains how they work there. So basically, but real quick, you have a label which is like a digit from 0 to 9 followed by a colon, for example, 1 colon, and then that is a temporary label, and you can refer to it from some line before the labeled line with a 1F. That would mean the first label 1 in the forward direction, or a 1B, that is the first label 1 in the backward direction. And so here's how that works. The assembler has two passes. The first time you go through the source file, you're just looking to find the value of all the labels. The second time you go through the source file, you're going to actually generate object code. So if you remember with the named labels, I allocated blocks of 32 bytes. And then I split each block of 32 bytes into two symbol table entries of 15 bytes each, and then a 2-byte pointer to the next block. And the reason I did that, the reason I have those 32-byte blocks of memory allocated by my malloc subroutine, is because it's a very convenient size, both in that case, because it gives me 15 bytes per symbol table entry, which is enough to have 12 bytes of characters, so the symbols can be 12 characters long, plus 1 byte of the type, plus 2 bytes of the value. But also, for the numeric labels, I can use those same 32-byte blocks. And in the case of the numeric labels, a block of 32 bytes, here's an example, will be split into 16 2-byte values, the last of which is a link to the next block, shown here as null because there is no next block. And the first 15 of which are 2-byte values of labels of the numeric labels. All right, and so what there's going to be is there going to be 10 pointers, each of which is the head of a linked list of these blocks, and then there's going to be 10 copies of backward and forward pointers, quote unquote pointers, because they're not exactly just addresses. These pointers are just addresses. These pointers are actually the address of the block plus an offset into the block. So although I've shown this as being a pointer to here and this as being a pointer to here, in reality this will be not a 2-byte pointer, it will be a 3-byte data value, 2 bytes being the pointer to this block and 1 byte being then the offset into the block. And so what happens is in the first pass, when we go through, every time we see, in this case, a 4, because these are the variables for 4, if we see 4 colon, that's a numeric label, a temporary label, it will then take the address of, or the location counter at the point it sees that label and enter it into this block, and then advance the pointer. Advance things. So for example, when we first start reading a source file, there will be no labels at all. So this 4B will be null. It's not pointing anything. And then when we see a 4 colon, this will point here. This will be pointing to the first place, and then the location counter, or the value of that label, which in this case is hexadecimal 10, will be entered here. And then the next time we see a label 4 colon, this will be advanced here, and we put in the location counter value, which in this case would be hexadecimal 63, and so on and so on and so on, all throughout the entire source file. And then when we start pass 2, the second pass, what will happen is that this will start off the second pass with this, so that at the beginning of the second pass, if we see a reference for F, that means this here. Whatever is here, it will mean the location hexadecimal 10. When we actually get to the first label for colon, then this basically will get moved here. What we'll do is we'll take this and copy it here, and we'll advance this to the next one, like that. So then at that point, after we've seen the first 4 colon temporary label, for F, that is a label 4 in the forward direction, we'll refer to this one here. And for B, the label 4 in the backward direction, we'll refer to this one here. And so on. The next time we get another label, these will be updated again. This will get moved here. This will get moved here. So after the second 4 colon label, temporary label, numeric label, for F we'll refer to this, and for B we'll refer to this. And so on all the way through the source file. Okay, and the advantage of this is that these numeric labels, instead of using 15 bytes per label, use only 2 bytes per label. Yeah, I think that's correct. I'm just now thinking in my mind whether it might be necessary to store the type of the label. They're always relative, but they could be a text segment label, a data segment label, or a BSS segment label. But I could do that several ways. I could store a type here, or I could have a separate, these things for text, BSS, and data, which I probably might do. That sounds like a good idea to me. Anyway, that's how these things work. So since I've decided in the last installment to recognize these numeric labels in the scanner, I'm going to have to write the code to handle this stuff, to actually insert, to build these linked lists of numeric labels, and to insert the appropriate values into the into these spaces here. So using numeric labels does use up space and memory. It does cause, that uses something, but it saves a lot of space compared to named labels. So that way you won't have to worry about running out of symbol table space as quickly. And also, these type of numeric labels mean that we just use numbers to refer to certain parts of the program, instead of having, like you've seen when I've been writing the code, I have labels like get name 0, get name 1, get name 2, get name 3. The reason I have all this is because I don't want to waste my time trying to think of different names that are meaningful for every little piece of the program. If you know what you're doing when you read the assembly code, you can understand it, and you don't need to have special labels, special names for these labels to help you figure out what's going on. So in the same way, these numeric labels, they're just numbers, and they don't have a meaning associated with them, but they are a way to refer to certain places in the program, like branch targets and stuff like that. So anyway, that's the goal today, is to get to work on this stuff right here. And let's do that. So we'll go back to the emulated Apple II, Apple IIe, and let's look at AS0, because that has the scan routine. All right, this is the part we did last time about unscanning stuff. What we need to do here is look for where we find numbers. And in particular, we're looking for not hexadecimal numbers, but for regular numbers. Here it is, okay? So regular numbers, we're going to, and if we see a regular number, so if it's something which is greater than a 9, we go to scan 8. Right? If it is less than a 0, we go to scan 4 down here. Otherwise, we unget the digit and we jump to get dec. So that's what we need to go look for, is get dec. There's get hex, get dec. Here we go. So get dec is called with a valid decimal digit having been already read and ungot. So we're going to, all right, here's the end of the decimal model. So at this point, when we get here, we've gotten some character in the input which is not a digit from 0 to 9. So we unget it and return tnum. We want to change this now so that we don't return tnum. In fact, we just return, we need to, check to see if what we got is not a, okay, get dec 9. Oh, we've got all sorts of labels available to us. Okay, so get dec 9. We need to compare to see if this thing is a colon. If it's not a colon, then we'll just do like we always did. Okay, so if that last character, which is not a digit from 0 to 9, is not a colon, we unget it and we return tnum. Otherwise, if it is a colon, we don't unget it and we return tlab, tnlab in numeric label. Okay. Oh, well, actually, we have to do a little bit more checking than that. I'm just thinking, I'm silent here because I'm thinking, where do we want to actually build this whole data structure here? Do we want to do it here when we recognize that we have a numeric label, or do we want to do it in the parser when we see a numeric label there? And I'm thinking in this case, I'll probably do it in the parser. Well, the code I wrote last time assumes it was already done though, so maybe I should do it here. Maybe I should do it here. All right. Let's see, if it's equal to, if it's a colon, let me do it this way, slightly different here. All right, so if it's a colon, go to get dec 8. All right. All right, so we get something which is not a digit. We check to see if it's a colon. If it is, go down to get dec 8 because it's a numeric label, probably. Otherwise, it's not a colon, so we're going to unget it and return number. Now, if it is a colon, we still have to check and make sure that the token value is within range, right? And I actually did this last time, but then ended up deleting that code, but now we're going to have to do it again. So we're going to get the high byte of tokeval, and if it is not 0, then what we'll have the situation, what we have here is the situation that someone, like this would be a valid numeric label, but someone has typed something like, I don't know, 1072 as if that were going to be a numeric label, and that's not allowed. So we could handle this in two ways. It's an error no matter what. It's either an expression which has a colon in it, which it should not, so it's a parse error or an error in an expression, invalid expression, or it's an invalid numeric label. I think I'm going to just treat it like an invalid numeric label. So that means I can go ahead and put here okay, invalid numeric label. So if the toke file is equal to 0, actually, let's say if it's not equal to 0, I'll go to getDex7. And this was just a demonstration. I don't need that there. All right. If it's equal to 0, then I still need to check the low byte of Tocqueville and compare that to a 10. If it is greater than or equal to 10, then it's going to be an error, an invalid numeric label. All right. Otherwise, so for invalid numeric label, what we'll do is we will load I'm pretty sure this is here, in lab error. If I remember correctly, this is what I want to do. Just load the pointer to the message in X and Y, and then is it jump or I guess JSR to error, something like that. Now I forget. I've forgotten. What do I do? How do I, if I get something bad? Oh, jump error. It's going to flush input and return. Okay, fine. Jump error. So no JSR. Jump error. Okay. And I will, actually what I'll do here is if it's less than or equal to, if it's less than 10, I will branch to getDex6. Actually, I won't even call it a getDex6. I will call it numlab, numeric label. Because conceptually, this is a little bit different. Conceptually, at this point, I know it's a numeric label, and it's not a number. So this is the place where I would, okay, so all this is basically getting a number, and then we see, hey, that number we just got was followed by a colon. So let's go down here and check what number we got. If it is a number greater than or equal to 10, then we'll just say it's a numeric label error because it looks like a numeric label, but we only allow numeric labels to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Otherwise, at this point, it is a real numerical label. We know it is. And so I'm not going to call it getDex anymore. Now it's called numlab. And we need to build this. Oops. Okay. Now I'm just thinking this source file is 90% full. So I probably don't want to put all this code here. It might fit, but it might not. So I think I'm going to go out to my, what I'll do, in fact, is call this getDex6. And getDex6 will simply jump to numlab. Okay, so it will just jump to another routine called numlab. Or I could just do it like this, like I did just a minute ago. So if it's greater than or equal to 10, branch to get dex 7. Otherwise, jump to numlab. Okay, that looks fine. So once we get the end of our digits, we say, is it a colon? If it is, we go down here. Otherwise, we unget whatever character it was and return number. If it was a colon, we just check to make sure that the number that we just read is less than 10. If it is less than 10, we're going to end up jumping to numlab. If it's greater than or equal to 10, we're going to go down here and say invalid numeric label. And that's good. Whoops. Okay, so save. And AS1 back here. This one is only 70% full, so I think we have room for our numeric label stuff here. I want to put it near the symbol table, the other symbol table stuff. So we're going to put it not there. This is all debugging code that just prints out stuff. All right, here's the symbol table stuff there. And actually, I'm pretty sure we don't use this mem error thing, the symbol table, because, well, malloc, it's malloc that uses it, isn't it? Yeah, it's called from malloc. That's fine. Instead of saying memory exhausted or out of memory, we just say symbol table full, because that's the only thing we're allocating memory for in the first place. Okay, so I think that's fine. I'll just check to be sure. Yeah, it's in malloc. Okay, good. All right, so here it will be numlab. And actually, I just think I'm going to move this up towards malloc so that it's up there instead. All right, I'll put it right here. There. And this is the code to look up named symbols in the symbol table and to put them in there if they're not in there already. And this is going to be very, very similar. I mean, similar in the sense it will allocate memory. But here it's like this. So it's going to be similar in the sense that it may have to allocate memory. And what we'll need to do is we will now see, now here's a pointer for each of the possible numerical labels for numerical label 0, 1, 2, 3, 4, 5. Each of them has its own list. So we're going to need to allocate that space. All right, so I can call it NL pointer. Yeah. And that is 10 pointers, 2 bytes each. That's going to be 20 bytes. And then I need for each of these numbers, 0 to 9, I need a front pointer and a back pointer. And like I said a minute ago, these pointers are not purely addresses, although maybe they could be. The reason I was thinking they should not be purely addresses is because I need to distinguish when I've hit the end of the block here. I need a new block, but I could do that pretty well also just by saying, Now this is intended to be a pointer to the beginning of the list. If I have multiple blocks, then this needs to be a pointer to the, this can be a pointer to the block. Yeah, I think it's better. These things will be a pointer to, they actually will have a pointer to the front of the block and an offset into the block. Then if that offset becomes 30, then we'll know, okay, we're at the end of the block and we need to allocate a new block. So I think that's the way we'll do it. So we'll need a pointer and an offset. So that would be 3 bytes, 2 bytes for the pointer, 1 byte for the offset. So we can call this NL front, and that's going to be 30 bytes. 3 times 10. NL back, 30 bytes. Okay, so these 80 bytes here is all of these things here plus all of these things here. In this picture, this diagram, I've shown only one for four, a back and a front for 4, but actually we'd have to have one for each of these. Okay, and they all start off 0. They're all initialized to 0 by default. That's fine. All right, and we are definitely going to need to use the 0 page pointer here, so I'll go ahead and obtain a 0 page pointer. Okay, and at some point we'll have to exit. Okay, so this is where we're leaving this subroutine. Here's where we enter the subroutine. We obtain our 0 page pointer. We deallocate our 0 page pointer, put back whatever was there before. All right. So when this is called, there is a numeric label in, we have recognized a numeric label. Oh, that's right. We're also going to return token in lab. We've recognized a numeric label, and the number is in tokeval, the first byte of tokeval, the low byte of tokeval. So we can load x tokeval. Load a tokeval, and then multiply it by 2, and then put an x, and that will give us an offset into this thing here. Actually, it's a pain in the butt to multiply things by 3, so I don't want to do that. So I'll call this NLF pointer, and that would be 20 bytes. And then NLF offset will be 10 bytes. So we'll just separate that stuff out into 2 separate things. I'm sorry, this is the back pointer. Off. Like that, okay? So, and I called this pointer, I'm referring to these things here. What they really are is they're the heads of these linked lists. So maybe I should just call it head. That's what these are the heads of the linked list. Okay, so now this is nicer. I don't have to multiply anything by 3. Okay, so I've gotten my label value, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've multiplied it by 2 to get an offset into this array here. And I put it into X. And the reason I'm doing this, well, do I need to do that? I think actually I don't need to look at this here, because this will always point. I need to keep this pointer because when I begin pass 2, I have to reset these things to point at the beginning of the list. But I can just check right now, check these to see. When it's pass 1, I'm going to be putting these things in here. So actually I have a little bit of work to do here. I have to do different things for pass 1 and pass 2. I have to do different things for pass 1 and pass 2. So the pass variable, which will tell whether I'm in pass 1 or pass 2, I'll put in the first source file, AS0, So just I'll use it here. I will assume I'm going to use it. But what I need to do now is I need to look and see. So if it's pass 1, the first pass, then I need to take the value of this label and put it in the next slot. And when we start off, this will not be pointing anywhere. All right, so I think what I'm going to do is like this. I'll get my offset here in X, and then I will load the pass variable, which I haven't made yet, but I will. And although I talk about pass 1, pass 2 when discussing how the assembler will work, the variable actually contain pass 0 and pass 0 and 1. The value of the variable will be 0 for the first pass and 1 for the second pass. So what I will say is if it is not 0, then go to numlab 1. And then this is the pass 0 stuff. Okay? So for pass 0, what's going to happen is the first time I see any numeric label, this thing will be null. So I'm going to load, and sorry, that's going to be a back pointer. Okay. NLB pointer, comma X. And the only time this would be 0 is if this is the first time I've ever seen this particular numerical label, numeric or temporary label. So I'll just assume it's not 0. And I'll change this to like numlab 5, whatever. So numlab 1. All right, so now I have the situation that it is 0, which means I have to allocate a new block, which means I JSR malloc. And that will always succeed, or it will have ended the program. But it will always succeed from my point of view here. So I'll take that X, that value. Aha. Yeah, I need to not destroy, I need to remember my value of X here. So anyway, I'm going to take that value and store it in NLB pointer. Well, X and transfer Y to A and store that in NLB pointer X. So my new block we pointed at by this thing here. Okay, and now before I jump to malloc, I need to save the value of the X here. So can I do that easily? I'll probably just do it like this. Okay, store it there. Coming back from malloc, first put TXA, and then load X. Zero, of course, is not going to be 0. It's going to be whatever was stored there. Wow, which could be 0, right? So I'm checking this pointer If it's not equal to 0, that means I already have a block allocated. If it is equal to 0, I don't have a block allocated, so I have to remember the value of x by storing it here, call malloc to get a block, and then the address of the allocated block of memory is returned in x and y. So move x to a, reload the value of x I need, store that, and store y. And this actually should be +1. Okay, so when I've done that, then I now have my pointer here that I need to have. And I also have the offset, the back offset has to be set to 0. Okay. And to do that, I need to move x to a, divide by 2 again, move it back to x. And that's going to be NLB off. Okay. So at this point, I've allocated a new block, and I have put the pointer part of this to point to the beginning of the block, and the offset point of this to be 0, so that it's referring to this first thing here. All right, and now all I have to do is I have to put the address of this thing right here in Tocqueville and return. Okay, so, and that address is the address here of NLB pointer. It's this thing here. So I can actually just store that immediately in Tocqueville. All right, and now I can, well, let's just do jump. Jump to numlab 9, which restores my 0 page locations and loads tnlab and returns. Okay, that looks nice. All right. Now I need the situation where this all handles the case where this is the first time I've ever seen a label, and this is all empty, empty, empty. Oh, I need to store it here too as well. Let me make sure I do that. This was all empty, and I had to allocate my very first block for the label. Okay, this is dumb because this is 2 and this is 4. Actually, since these are 4, this should be 4. Anyway, if you noticed that a long time ago, good for you. Good job. All right, so I also need to store this value returned by malloc here in this thing, which is called, that's the array called NLhead. All right, and fortunately, it's just that, like that. Okay, good. Now we have the situation that we already have a block here, right? And so, for example, now let's erase this because we're talking about first pass here. We have a situation that we store this. Now we see a new label 4. So what we have to do is first move this forward, and we move this forward by increasing the offset. Okay, we move this forward by increasing the offset, and check and see if the offset is 30 or not. If the offset is 30, we've just moved it here, and we need to allocate a new space. If the offset is not 30, then we just move it here, and we can just return this as the place that we need to store the value of the label at. Okay. Okay, LB pointer X. Okay, good. So here we are. Just thinking to myself, because actually I need to, at this point, update the offset, which means X, I already multiplied X by 2 here. So I'm going to have, and I multiplied X by 2 in order to be able to check the LB pointer array. But now I need to have it divided by 2. Maybe I can, before I multiply by 2, I can put it in Y. So the unmultiplied version is in Y, the multiplied by 2 version is in X. That doesn't change any of this code down here. We end up blowing away Y when we call malloc, and that's fine. It just means I have to divide by 2 again here, which I'm already doing anyway, so that doesn't matter. So at here, I can use Y instead of X, and I'm looking for NLB off. In NLB off. All right. And actually, I need to increment it. Instead of loading it, I should increment it. Okay, I'll do it the easy way. Okay, it has to be incremented by 2 because each of these things are 2 bytes wide. Well, since I'm going to have to load it into A to check anyway, let's just load it like this. Is this better or worse? I don't know. Okay. If it is, well, hang on. Jump to numlab 2. Okay. All right. Add to 2, and then compare to 30. If it is less than 30, or actually I should say if it's greater than or equal to 30, go to numlab 3. If it's less than 30, then I'm done. I just need to put the address of this thing to, well, let's just put it back. No. Okay, so get the offset, add 2, compare to 30. If it's greater than 30, go to numlab 3. Otherwise, put the offset back because it's fine. There's nothing wrong with it. And we need to now take this new offset and carry is clear because of this. So we need to add this to NLB pointer X, store that in Tocqueville, and just there might be a carry. So I just go ahead and do it with a full 16-bit add. I don't want to burn another label right now. I mean, come on, it doesn't matter. Oh, by the way, not add, ADC. Store that into file +1. And jump to numlab 9. Okay, so this is the situation, let's just go over this quickly, where this thing is not null. That means we already have a block. It's pointing to the pointer part of this is pointing to the beginning of the block. The offset part is offset, has a value 0, 2, 4, 6, 8, 10, so on like that. And what we're doing is we get the offset and we add 2 to it and see if the result is 30 or not. If the result is greater than or equal to 30, although actually it will only ever be 30 exactly, then we'll go down to numlab 3 down here because we'll have work to do down there. If it's less than 30, then all we've done is we've moved, like I show here, we're pointing at an empty space in this block. So we go ahead and store that offset back into the offset array. And then we add the offset to the pointer, that is to the pointer to the beginning of the block here, to produce the address of this entry here. Okay? And we store that in Tocqueville. And then load A0, add the high byte of the pointer, and store that in Tocqueville +1. This is just, what we're doing is we're calculating the address of just these 2 bytes here, the address of the first of these 2 bytes, and we're storing that in Tocqueville so that the parser, when it sees a numeric label, will then store the value of that numeric label right there. That's the idea. And then once it's done that, it has the address of this space has been stored in Tocqueville. We're done. We jump to numlab 9. Okay. If we did get a 30 here, that means we've run into this and we need to allocate a new block. Okay. So that means that again, we should probably remember the value of x here. Let me just do that. JSR malloc to get a new block. Okay, we need to store it. Now, last time when we got a block, because it was the first ever block, we had to store the address of it here in the 4B pointer. We had to store it here, and we had to store it in Tocqueville because the address of the block is the address of the first thing in the block, and that's where the value of the numeric label is going to go. In this case, we don't want to store it here, but we do want to store it here. The new block, the address of the new block has to be stored here, and in Tocqueville, and down here. Okay, so JSR malloc, and I move x to A, and all right, retrieve the offset. And store the malloc, the address of the malloc space into NLB pointer. That is, we've allocated a new block. Oh, actually, I don't want to do that yet. We've allocated a new block, and we want to store, ultimately we want to store the address of the new block here, but first we have to store it here. Okay. So before we actually do this, thinking here. Okay, this offset is, when we come down there, the offset is in A. The offset 30 is in A. Yeah, that doesn't matter so much, does it? Okay. All right, JSR malloc. Let's just, so the first place we need to store it is here. And the only pointer we have to this block here is the pointer here. So what if we, okay, we save the offset that we need. All right, and we reload, reload the offset here. All right, and now we can get this pointer and store it in our 0 page location. That means we're getting a pointer to the last block, the one that's full now, in our 0 page location. And now we can get an offset of 30 into that block. We can't do that yet because the high byte of this address returned by malloc is in Y. Oh yeah, and actually we've moved the low byte of the address returned by malloc into A and then proceeded to blow away A. How about if we just push these on the stack? So we're going to take the address returned by malloc and just push it on the stack. That way we don't have to worry about it for the time being. We get our offset back. We store the pointer into our 0 page location, and now we pull the pointer from the stack and store it in the block. Increment Y there. Okay, so we take the address that returned by malloc and push it onto the stack, high byte first, low byte next. Now we retrieve our offset, and this offset is the offset that refers to which numeric label it is. This offset X is 2 times the numeric label. So if it's 5 colon, then this is 10. X is 10 here. Okay, so we get the NLB pointer, which is the pointer to the block that is full. We store that in the 0 page location. Now we get offset of 30, which will be this right here, into Y. We get that address returned by malloc off the stack, low byte first, and store it here, high byte here. All right, that's all of that. We also need to store this information, this byte here. And that is still, we still have the X variable available to us. So we can store this in NLB pointer, NLB NLB pointer X, NLB pointer plus 1 X. Okay, so we've now stored the address returned by malloc here and here. And we also can store it in Tocqueville. Right? Because the new block, the address of the new block is also the address of the first thing in the new block, and that's where we want to put this location. All right, and that's all good. So now we can go ahead and return by jumping to numlab 9. Okay, by putting it here, we're linking the newly malloc thing to the old one. So we'll have a head will be here, first block, link, next block, next block, and so on. By storing it to NLB pointer X, that means this thing is now going to be updated to point to the new block. Oh, we do need to make sure this offset is 0, which we haven't done yet. The NLB off needs to be 0. NLB off. Okay, and we can do that here. So move X to A, divided by 2. Oh, this one need A there, I forgot that. I always forget that stuff. Okay. And actually when I first did the ASL, that I need it there as well. Okay. And then load 0. NLB off X. Okay, good. So now I'm just thinking this code here is almost identical to the code up here. Right? Here I just moved X into A, but what if I went ahead and pushed, sorry, not like that. What if I went ahead and, actually I would do like this, move Y to A, push it, move X to A, push it. Okay, now get my X back. And notice now I'm storing it in, oh, I'm just going to move this around like this. NL head.x, comma X. NL head plus 1, comma X. Okay, so what I'm doing is I get my pointer. If it's 0, I go down to numlab 2. Otherwise, I save my X. I call malloc. I push the malloc address, the address returned by malloc, onto the stack. I get my X back. I store it in the head that is here. I store it in the NLB pointer here. And I store it in Tocqueville. All right, and I'm using Y here. Oh, yeah, that's because I wasn't pushing it. So actually, yeah, here I need to right, this is going to be pull Y. So this is the high byte now. So just do like this. Okay, get the low byte. Okay, then get X, divide by 2, and store that in the offset, and then jump label 9. I'm changing this around to make it more like the code down here because the code is almost identical. So what I want to do up here actually is put, here I'm putting this pointer into the 0 page location. Right. Actually, so what I'm doing here is that I'm putting the pointer, which actually points up here. Whoops, didn't mean to do it that way. The pointer part of this actually points up here to the same place that this pointer points to. Okay, and I'm putting that into the 0 page location so that I can then use an offset of 30 to store things here. So what I'm thinking is I can also use the 0 page location to point at this thing right here. So I could use the same code. The 0 page location will point here. I can store that there. But this one is offset by 30, and that one would not be offset by 30. Oh, here I'm pushing the high byte, then the low byte. Oh, wait, why did I do that up above? So I'm pushing the high byte, then the low byte, which is the usual way to push a 16-bit value on the stack. So I need to pull the low byte and pull the high byte. That all makes sense. Why did I do it the opposite way up here? I don't know. Just a dumbass today. So push the Y byte, right. So this is actually all wrong. This needs to be like that because it's the low byte. Here's the high byte. Okay. I would like to unify these two things. And I can do that, perhaps, by loading NL head no, instead transfer X to A, because X is the offset into the NL head array and the NLB pointer array, but that's clear carry. Transfer X to A. Okay, add and store that in my 0 page location. All right, and store that in my 0 page location. Now my 0 page location points to the correct element of the NL head array because I've added my offset to it. And now here I can do not NL head X, I can do Y. All right. All right, and just like I did down here, I have to increment Y. Right, I did it right there. Okay. So I see if this pointer here is null or not. If it's null, then I don't have any blocks yet, and I have to allocate it the very first ever block. So I'm going to do that by first getting the address of this thing here. So in this case, since this is 4, x would be 8. I add that to the address of NL head, which gives me the address of this entry right here. And I store that in my 0-page location. All right, this is just doing a full 16-bit add to get the high bit, any possible carry stored in the 0-page location. Okay, once I've done that, I'm ready to call malloc, so I have to go ahead and save my x value, because my x value is my offset. My x value is 2 times the numeric label. So if the numeric label is 4, it's an 8, and it's my offset into this thing, it's my offset into this thing. So I store it, I jump to malloc, I push the result of malloc, I get the x value back, I pull the result of malloc. I also have to set y to be 0 here. Okay. So I get the low byte of the address malloc return. I store that through the 0-page pointer into this location and into this location and into tocval. Then I get the high byte. I store it here, here, and tocval. All right. Now I divide my x by 2 again, which gives me an offset into the NLB offset array, because those entries are only 1 byte each. And I zero it out, and I jump to numlab 9, which means I'm done. Okay. So when I go to numlab 2, which means that I already have one of these, but now I need to check and see if it's full. All right. Then what I need to do is, if it's full, okay, this is the case where it's not full right here. This is the case where it is full. Then what I really need to do is I want to basically, I have to set up the 0-page pointer. All right. And here I set the 0-page pointer to be just the same as this here. Wherever remember, this is actually pointing to the beginning of the block. But instead, I actually need to, because of the code up above, I need to add this offset of 30 into it. So when I get here, see, I have add to, compare to 30. If it's greater than or equal to 30, actually equal to 30, go to numlab 3, otherwise store it there. So I come to numlab 3, I already have that 30 in A. And carry is set. So yeah, I'll just go ahead and clear carry. Add that to an NLB pointer, X. Store that in the 0-page location. Load 0, add to NLB pointer plus 1x, store that in the 0-page location. Okay, so now I have set up the 0-page location to point directly here. It's pointing directly at this space. And I think, although it's just a think, that right now that I can just jump up here. But where do I jump? Okay, here's where I'm setting up the 0-page location here. store X. So this looks like I should jump right here. Okay. I'll call it numlab4. Because I've just, down below, I've just set up the 0 page location. And I do the same thing here. I want to jump here, save X, call malloc, and blah, and all that stuff. Okay. numlab4. And then all this can go away. Okay, so numlab2 is the case where I already have at least one block here. All right, I get the offset, my current offset into the block. I add 2 to it. I compare it to 30. If it's less than 30, then I store it back. And I take that offset and add it to the NLB pointer to find the address of the free location here. And I store that into a val, and then I'm done. If the offset was increased to 30, that means I'm pointing at this place, which is a link, not a place to put a numeric label value. So then I have to instead go down here, and I take that offset of 30 and I add it to NLB pointer. And I store that in the 0 page location. And I jump to numlab4, where it will then create a new block. Okay, so I put it in the 0 page location and jump to numlab4. Here, where it saves X. Remember, X is referring to which numeric label it is. Calls malloc, pushes the result to malloc, gets 0 in both X and Y, gets the low byte, stores it in the pointer, stores it wherever this pointer is pointing to, which in the case I just talked about is here, but it could be here. Stores it in the NLB pointer and in the toke_val increment blah blah blah. Then it has to set the offset to 0. So it has to divide X by 2 and store there, and then done. Okay, that looks good to me now. So now we have the situation to deal with that is not past 0. All right, that's all for past 0. If it's not past 0, now I think what I'm actually going to do is say if past is 0, I'll go to numlab5, which will be here. Right, and the reason is because past 0 code is going to be actually more complicated than the past 1 code. Yeah, I think that's all good. Okay, so the past 1 code, the thing that's different about past 1 code is I don't have to allocate these blocks. They've all already been allocated. In the case of past 1 code, when I start the source file, the forward pointer is going to be set up to point to here, and that's going to be done in a different place. Like before I start reading the source file, I'll just copy this to here and set the offset to 0. And so when I actually see a label in the code for in the first pass, in the second pass. I'm just going to move this to here, right? And then I'll take this and, well, I'll move this to here in the sense that it'll get copied, right? And then I'll just update the offset of this one to go to the next one. And if the offset happens to be 30, I have to follow this link and get to the next block. So that's really what's going on. So the first thing that happens is I load NLF pointer X and store an NLB pointer X. NLF pointer plus 1X, store an NLB pointer plus 1X. Now I have to, oh, and I have to do the offset as well. So load NLF off Y, store NLF off, I'm sorry, NLB off Y. All right, now I just have to update or increment NLF off. So I just stored it, so now I can go ahead and add 2 to that and compare with 30. If it's less than 30, I'm done. So I'll actually say if it's greater than 30, go to numlab 6. I think what numbers have I used? 5, 4, 1, 2, 3, 9. Okay, good. 6. If it's greater than or equal to 30, go to numlab 6. Otherwise, it's less than 30. I'm done. Actually, I have to store it back. Store NLF off Y, and then jump to numlab 9, which is the exit. Okay, so move the front pointer to the back pointer, move the front offset to the back offset. Now I have the front offset here, I add 2 to it. If it's 30, that means front is pointing here. I have to advance to the next block, but I don't have to allocate a block, I just have to follow this link. Otherwise, if it's less than 30, everything's great. And I just store that updated front offset and exit. All right. Now, at this point, I have to follow the link. So I need to, well, I might as well just take NLF pointer and store that in my 0 page location. Oh, there we go. Okay, store that in my 0 page location. All right, and get the link pointer here and store that in NLF pointer. X, increment Y. Okay. So what I'm doing now is I'm copying this here, so that this is now not pointing at this block anymore, it's pointing at the next block. Okay. I forgot to set Y to 0, but before I do that, I think what I ought to do is go ahead and set the offset NLF off Y. And so I set the offset to 0 because it's going to be a new block. Are we just moving to a new block? So the offset will be 0. And then I will just move that 0 into Y, which is what I need down here. Oh, wait, no, I need Y30 in Y, and there it is. Okay, hang on. That can go away. Move 0 into Y, put 0 into the offset, then get the pointer to, right, and from LF pointer, that's the pointer to this old block that we've now run all the way through, and store that into the 0 page location, then use the offset of Y so we access these bytes from that block, which is the link to the next one. Yeah, and we load that and store it back into NLF pointer. That makes, in other words, we're moving this, instead of pointing here, it's pointing at the next block. All right, that all looks good. So now the front pointer is pointing to the next block. The front offset is set correctly. So that looks good. Right? I think that's it. Yeah, that's it. Now notice in the first pass, I don't need to put anything in Tocqueville because I don't care. I'm sorry, in the second pass, I'm getting confused. I'm confusing myself by saying pass 1 and pass 0. This is actually pass 1, this is actually pass 2. Let's just say it that way. Pass 1 is the first pass 2 is the second pass. However, the pass variable will store a 0 and a 1. Yeah, so maybe it should say 1 and 0. Pass 0 and pass 1. Anyway, in pass 0, I have to have that token. I have to have the pointer, the address of this thing in the token value so that the value can be stored in it. In pass 1, the value has to already be there. If in pass 1 there is no value, that's an error. And so we don't need to bother with that. Okay, we just have the case of either my forward pointer is not at the end of the block yet, or my forward pointer is at the end of the block yet. Either way, that's good, okay? All right, good. So let me just put in a few empty lines here, because lookup and numlab are different things. Numeric labels. Okay, and this code looks pretty decent. All I need is this pass variable, which I said I'm going to put back here. And of course, it's just a 1 byte variable. Pass. It has to be entry as well, though. Okay. Just make sure I didn't forget anything or screw anything up terribly. 2 errors. Duplicate label numlab 9. Okay. I'll go take a quick look at that. Oh, this was just supposed to be numlab. Hang on. But not get confused. Where am I? Right, this is supposed to be on map 6. Right? Right. Still an error. Unresolved reference numlab. Okay, it's not. It needs to be an entry point. That's all. Numlab. Entry point. Okay. So to symbols. That doesn't mean it works. That code I just wrote could have errors. I'm going to look at it off screen, and eventually we should probably write some code to test it out a little bit and make sure that the numeric labels are being inserted correctly. Like we might need to write another dump routine to dump out numeric labels to make sure that they're getting good values. But that will be for a future time. So for now, that's all for this installment. Let's see you next time.